it's me again, Wolfgang, and this time I'm going to talk about a topic that is less related to Raspberry, but rather than that, I want to show how we can use one of the key technologies behind Raspberry, that is the INDI library, to, let's say, uncable our telescopes a little bit. When we take a look at a more sophisticated astrophotography setup, and I just Googled the term astrophotography setup in my web browser here, we see that pretty soon we end up with a humongous amount of cables, devices, power supplies, and so on. It is naive to assume that we will see in the near future the one wonder device that does it all, that does guiding, telescope control, sequencing, image acquisition. But I want to show you a way how this can be simplified a little bit, and this will be done by means of the INDI library on an inexpensive Raspberry Pi3B. While I do not recommend to use the 3B for a sophisticated setup like the Astroberry server, it is still powerful enough to run a simplified version of the Raspberry Pi operating system called Raspberry Pi OS Lite. And I will show you how to download and install Raspberry Pi OS Lite, how to configure it, and how to set up an INDI server on that one. Raspberry Pi OS is available from the Raspberry Pi Foundation homepage, and I strongly recommend you to download the installer for Raspberry Pi OS, which is available for all operating systems. In this installer, you can select the operating system, and we want to install Raspberry Pi OS Lite in this case. And you can also select the source where you want to install your operating system image to. Once all of this is done, you can insert the SD card in your Raspberry Pi 3B, and you see how it starts up. The special thing about Raspberry Pi OS is that it does not feature a graphical user interface. This sounds uncomfortable, but you will see that this has quite some advantages. Here I am logging in to the Raspberry using the secure shell. And I'll show you in a second how this can be activated. I did this prior to shooting this video because I wanted to be able to get a nice screenshot of the terminal here on my Ubuntu 21. So I'm now logged into the Raspberry, and I run a configuration program called raspi-config. I do this as a super user. It is noteworthy to say here that I did not connect a display or a keyboard to the Raspberry Pi. I logged in via an Ethernet cable and my router. However, you can also do this by connecting your Raspberry Pi 3B to an HDMI monitor and use a standard keyboard for the same procedure. So here we are at the configuration menu. I am connected via a LAN cable, and now I'm also connecting to my wireless. It is possible to use both interfaces, and we'll see later on that this can be quite useful. The default password is Raspberry and the default user is Pi. You can change this here. Next, we see something that I've done already. We see how the secure shell server is being enabled. So, as I'm recording this via secure shell, I've done this beforehand, as said before. This step is very important. you have to set the Raspberry in such a way that it automatically logs in into the Pi account. In the end, we don't want to use our Raspberry as a computer. We just want to turn it on and use it as a server for our instruments. And for this we also need to set time zone, location and the Wi-Fi country. And this is being done here. It's also extremely important to set the proper keyboard, especially when you're living in a German-speaking country like I do, because we have Z and Y exchanged, and typing the password Astroberry or Raspberry can be quite frustrating in a freshly set up system. Of course, you can do all of this in a different way as well. You could also do it on a GUI version. And if all of this looks Greek to you, then you should maybe look into the standard documentation. After rebooting, your Raspberry is set up properly. Next, we're going to install INDI, which is the toolbox for talking to devices. We go to www.indilib.org. And here you see installation procedures. I'm opening up the secure shell on the right hand side. And I am not copying or typing the tedious commands you see in the installation section of this homepage. Rather than that, I'll show you a trick how to copy and paste from the homepage to the terminal. So here, with Ctrl+C, I can copy this line. I go to the Secure Shell terminal. I use Ctrl+Shift+V to paste this into the terminal. I press Return, and now this command is being executed. I repeat this for the next commands. Here's the third one. And now I'm ready to install INDI server, which takes a while. Of course, you need to be connected to the internet for this. And this is not KStars, not ECOS, this is just the INDI server. This is what talks to all of your devices plugged into the Raspberry. By taking a look at the INDILib homepage again, you can see what devices are being supported. And above all, when you click on the device descriptions, for instance, I will connect a QHI camera now, you see the name of the corresponding INDI client. In this case, it's INDI_QHI_CCD. By typing INDI server and the name of this client and an ampersand, which is extremely important because this makes this process a background process, I can start up now an INDI server. And I can connect any INDI client on a different computer, like in this case, KStars running on my Ubuntu box, to this INDI server. So I'm giving the INDI server a name here. I type in the Ethernet address and I type in the port to which the INDI server on the Raspberry reports. This is 7624 by default. We'll see later that it can be quite useful to change this. And when I'm connecting to this server, I have this camera available on my second computer running KStars, which is not the only INDI client you can use. And I'm ready to take photographs. Next, I want to start the INDI server automatically upon startup of the Raspberry Pi. I can, of course, attach multiple devices. And all I have to do is to open the file for the bash RC and add, for instance, the line INDI server and the name of the client I want to use, plus an ampersand in the last line. Of course, I can add more than one client, and I save this by typing Ctrl W, and I exit by typing Ctrl X. If I reboot now, the system starts an INDI server automatically. I connect to this INDI server, and here we have the camera. Everything's available. If I want to add more cameras from different vendors, I also have to add the drivers to the startup script as well. This is of course a little bit hard stuff, but all I've done here is well documented. So if you don't have, let's say, too much an idea of the Raspberry, it would be recommendable to take a look at all the tutorials for basic operation of a Raspberry Pi beforehand. The advantage, however, is clear. You have now a compact server for all of your instruments, cameras, filter wheels, whatever, and you can access them via a network connection. The next thing what follows is, let's say, a little bit of fine-tuning, that is how to use multiple networks, multiple servers, or how to use multiple clients. So this is already the advanced stuff now. First, let us start with connecting ECOS, the scheduler of K-Stars, to our remote server. I'm setting up a new ECOS profile, I'm connecting to a new remote host, but the INDI server is not running on the local host, it is running on my Raspberry Pi connected via LAN in this case. All I do now is start ECOS. We see that INDI comes up, the connection was established. And now I have my QHI camera available, and again I can take an exposure. I have to admit that I have to clean my sensor, but aside from that, that's ECOS with a remote server. Now let's see how we can address several INDI servers on different computers. So here I'm starting a server with an alternative port on the Raspberry. I need the alternative port because the standard port 7624 will already be used by a second INDI server on a different computer. The different computer is an autonomous hotspot being spawned by my telescope controller, something that is very similar to the stuff Stellarmate or RCR do. So I have two possible ways. I'm going to my Raspberry Pi with the changed port, and I also have here a connection to my telescope controller that is on a different wireless network and has a different IP address and a different port. So if I connect to both of these servers, I do now have the cameras on the Raspberry available, which is a Canon and a QHY, and I have control over LX200 on the controller via the second INDI server that is running on this separate controller. Here's again a shot from the QHY, and I can also issue go-to commands and other telescope control commands to the controller using the LX200 protocol. And finally, we can also see how we can have several clients on different computers. So here I'm starting an INDI server on the Raspberry that supports the QHI camera, and I'm starting a second INDI server on the same Raspberry with a different port. This is the -P option. And if you want to do this permanently, then you have to write this into the bash RC startup script. This supports a Canon DSLR, so I have two INDI servers running on the Raspberry. I'm now connecting to the Canon via KStars, via my Linux computer. This is the Canon. And here I have PhD2 guiding running on a Microsoft Surface with Windows 10. I can also connect to the INDI server, to the other INDI server with the different port. And here I have the QHY camera as a guiding camera up and running. I can connect over the network here as well. Now I have two clients on two different computers, one of them taking the guider camera images, the other one being connected to the Canon camera. Okay, so this is it. What I've shown to you is a simple and cost-effective way to provide a central server for multiple instruments. Once you've done this, the whole thing can be hardwired and you can have full access to your telescope over a network connection. That can be useful, for instance, for bridging the gap from your telescope to your cozy living room, or for distributing the various data sources to a second room in your observatory where you have, for instance, a control computer or something like that. The most important thing, however, is to take care of a sufficient power supply, because that is one of the major problems when people are using too many devices with an Raspberry or an INDI server based on a Raspberry like this one. Have fun.